Have any specific topic that you want me to go over again? Because I want to address all the questions that you might have first before I just kind of blanket it and start from the first topic. That is actually important. Yep.
On last Wednesday, you talked about loops and tracing loops and doing pre and post statements.
Mm-hmm.
Can you go over again the post statement for a loop?
Okay. Yep.
I was trying to practice on my own, and I was getting myself confused on how to write the pre and post.
Okay, we can do that. I'm trying to see if I can find any tool to draw something on the screen, but I can try this. I've not tried this before. Okay, let's see if I can make use of this tool. Oh, I can zoom here. So this is going to be my virtual whiteboard, and I'll try to draw the pictures here. And it's not going to look nearly as good as what I can do on the whiteboard, but I'll try. That's not going to work. Let me see. What am I going to do? Let's see. Can I? Nope. Not find a dry.
There's a marker behind the podium over here. It's like stuck.
Oh, okay. Thank you. Right. Thank you. All right, so what we'll do is we'll draw the picture first, kind of like last time. If you have copied the picture from last time, there's no need to do it this time because it's going to be exactly the same. So we will look at the program in pretty much the same way as last time. Okay. This is the picture of a post-checking loop, fairly generic. So what we'll do is we'll make it more specific. The condition to stay in the loop is x is less than k. We don't know what k is, okay? We don't know what value x is even starting with. We'll assume nothing in this case. The only thing we do inside the loop is x will get x plus 1. That's all we're going to do. And this is it. This is our example. And the objective of this simple example is to illustrate the relationships between the pre and the post conditions. And what I would also do is to use a text file to capture that, which is what I did last time. But unfortunately, since I did not upload the file, I did not upload the file. So this time, hopefully, I will capture both the screen recording as well as the file and put it online. Okay, so in this case, I would just say that line 1 is the loop already. While x is less than k, do. Line 2 is saying x gets x plus 1. And line 3 is and while. That's my entire program. Are we okay so far? Does the picture reflect what the pseudocode is saying? Okay, they're consistent. Very good. So now we want to label pre1, what is pre1? Now when we specify a precondition, we are specifying the condition at a particular section of this, of this trail map. This is pre1. In other words, every time I get to this point of the algorithm, whatever the condition has to be true, that will be the precondition of line 1. It is a guaranteed condition when I'm at that spot. Is that okay?
So is it because when we write the trail map, x is less than k, that's on the signpost to the trail, right?
Yep, this is the question to ask so you can determine whether you go this way or you go the other way.
So it's a precondition to even the post on
The
the trail?
precondition of which line?
Pre1.
Pre1? Pre1 is a guaranteed condition when I'm here.
So is it before or after?
It is before. Pre1 is before we even get into the loop or before we even check whether x is less than k. So the other points that are kind of interesting to us would be this point here. Whenever I'm here, what is the guaranteed condition? Now at this point, we don't need to really specify what it is. We'll just call this pre-2. Okay, we'll figure out what pre-2 is later on. Whenever we are here, we want to say, okay, what is the guaranteed condition here? And instead of really spelling it out, we'll just call that post 2, because it is right after the execution of statement number 2, which is x gets x plus 1. And the last one that is of interest to us would be here. Whenever we are about, or when we're exiting the loop, what is the condition that is going to be guaranteed? So that would be our post 3. So are there any questions about the labeling of the pre and post conditions in the picture? Is that okay? So the picture and the pseudocode have a one-to-one correspondence. And by using the picture, I can also show you what is the context of the pre and post conditions. They are basically at those specific locations. Any questions at this point? Yep.
We have a pre-2 and a post-2, but we only have a pre-1 and a post-3. Do we need
That is correct.
Post-1 or a pre-2?
I do not specify a post-1 because a post-1 is the same as a pre-2 in this case. Besides, it's really hard to say what is a post-1 because post-1 means, what do we do after line 1? And there are 2 places to go after line 1. We can go to line 2 or we can go to post in this case. We can actually just exit the loop right away. So I cannot say what is post-1 without knowing whether the condition is going to be true or false.
That's where I kept getting stumbled up.
Okay.
Okay.
So are we okay now with the pre and post condition labeling? Yep.
I have a generic question. From pre-1, is pre-1 always going to be given? Or?
Yes, pre-1 will always be given because, when you start your algorithm, you have to start with some assumptions. The assumption can be no assumption, in which case pre-1 is just true. Okay.
It's either true or given or false.
Oh, well, if the precondition is false, that means, it is a dead branch, which means, the rest of the code we cannot get to it. Okay.
I have a question. Along the same lines of what she was asking, there's no pre-3 because it's the same as pre-1?
Pre-3 is not, there's no pre-3 because we do not execute line 3 at all.
Okay.
Line 3 in this case is end while, which is nothing more than a label indicating the end of the loop.
Okay.
So since we're not going to execute line 3, it doesn't matter whether we spell out what is pre-3 or not.
Okay.
Okay, good questions. So are we ready to actually go in and put some values into the pre and post conditions now that we have labeled the pre and post conditions? Okay. So we'll start with an assumption of pre-1 because everything starts with pre-1. So we'll go ahead and say, let's assume pre-1 is true, which is basically a way of saying, so the comment here is to say, make no assumptions about x or k. That's all it's saying. Because true is the simplest condition that is guaranteed to be true, and it really doesn't say anything about the values of x and k or any other variables, which is exactly what I want. The more general the precondition, the more you are proving for the algorithm. Any questions at this point before we move on? This is good? Now,
If you don't give us a pre-1, we assume pre-1 equals true?
No, you have to raise your hand and let me know.
Okay.
Yeah, because I should give you a precondition in order to get started. Okay. Now we don't have to say it is, true, because, as we will see later on, what we can do with it. What about pre-2? Pre-1 is easy. It's going to be given to you, so you don't have to figure out what it is. But what about pre-2? Pre-2 is interesting in many ways, because there are really 2 ways to get to pre-2. One way to get to pre-2 is, this is the first time we get in, and this is how we get to pre-2. Is that making any sense? So one way to get to pre-2, if I want to spell out what is pre-2, pre-2, one way to get to it is going to be pre-1 and the condition that we are dealing with. Okay? I know pre-1 is as simple as true, but I do want to spell it out so that you guys can see that pre-1 is still true by the time we get to pre-2 because we did not have a chance to change anything up to this point. Is that okay? But there's also another way. There's another way to get to pre-2. The other way to get to pre-2 is we have completed at least one iteration of the loop. In other words, we are done with statement 2 at least once. So we go back after the statement, going back to here, making sure this condition is still true, and then end up at the same spot here. In that case, it is not pre-1 that is guaranteed to be true. It is going to be post-2 that is guaranteed to be true because it is a loop. So the other condition is to say post-2 is true, but I still need x to be less than k because if x was not less than k, then I would have taken the exit path and exited the loop. Is that okay so far? What I have on the board? Yep.
You said you've already done this before, correct?
Yes, I have.
Okay.
Yeah, but the second time I talk about it, sometimes it absorbs better.
I don't need to write it down. That's all.
Oh, okay. Yep, we have talked about it already. Yep. So now we can try to simplify the equation. Pre-1 is true, and the other side is just x is less than k. And then the other one is post-2, which we don't know what it is yet, and x is also less than k. So if you look at this, the first one is simplifying to x is less than k. The second one is post-2, and x is less than k. Now, this class is not about Boolean algebra, but I will show you, how we can also simplify this. You can simplify it so that it becomes x is less than k, or x is less than k, and I'm trying to remember how to simplify this. Okay. Okay, remember the and is kind of like multiplication, the or is kind of like addition. Using the distributive law, we can combine this into one. We can say, because one part is common, x is less than k is the common part. So I think we can combine it so that it becomes and that would be true or post-2. That would not make any sense. I must have made a mistake somewhere. Nope, that is right. I didn't make a mistake. In this case, it can be simplified because there's no assumption about the value of x. So I don't think this is exactly the same as last time. Is it exactly the same as last time? Last time, pre-1 is given... Did I specify what is pre-1 last time? Nope, last time is kind of interesting because I did not actually spell it out. So last time we actually did not finish the job. It was only done halfway. Yep.
You get it right at the end of the class. You're squeezing it in for the other class came in.
Oh, okay. So it's better to restart and actually capture the whole note again.